Okay, picture this. You are sitting in the exam hall. The air conditioning is humming, the clock at the front of the room is relentlessly ticking down, and you turn the page of your 0625 past paper. Suddenly, staring back at you is a massive, multi-part, 6-mark extended response question entirely focused on thermal radiation. For a vast majority of students, this exact moment is where the panic truly sets in. Let me introduce you to two types of students I see all the time in my physics classes. First up, we have Alex. Now, Alex is an incredibly hard worker. He studies for hours, but he completely overloads his exam answers with raw physics facts. He essentially vomits everything he knows about heat onto the page, but he provides absolutely zero structural analysis. And then we have Sam. Sam is constantly fighting the clock. He rushes through the paper in an absolute panic, and because he's rushing, he completely misses the highly specific requirements hidden inside the command words of the prompt. We've taken actual, heavily flawed answers from students just like Alex and Sam, and today we are going completely under the hood. We're going to see exactly how to transform those bleeding red examiner marks into beautiful green check marks. We are simplifying the absolute most complex concepts today because one single powerfully executed idea is easily worth 1,000 poorly structured words. So let's get right into it.
Listen to this carefully because it validates exactly why this specific topic feels so overwhelmingly challenging. Even the examiners themselves know it's a massive trap. This is a direct word-for-word quote from the Cambridge Principal Examiner report. They are flat out telling us, straight from the source, that thermal radiation is one of the most misunderstood areas in the entire physics syllabus. They explicitly note that candidates consistently confuse key terminology. Why does this happen year after year? Because students, exactly like Alex, think that if they just memorize the textbook definition word for word, they are automatically going to get the marks. But it doesn't work like that. When the examiner asks them to explain exactly why a shiny silver teapot keeps your tea warm significantly longer than a matte black one, students just scribble down "shiny reflects heat" and immediately move on to the next page. Let me be incredibly clear. That is a massive, catastrophic loss of available marks. They confuse the process of emission with reflection, they completely mix up their core vocabulary, and their final grades suffer terribly because of it. We are going to fix that precise issue right now by showing you exactly what the examiners are actually begging to see in your responses.
To get you those top-tier grades, we are going to structure this deep dive into 5 key examiner-focused sections. First, the thermal radiation trap. Second, core radiation principles. Third, the technical methodology. Fourth, critical examiner warnings. And finally, Section 5, your ultimate exam success blueprint.
Let's kick things off with Section 1, the thermal radiation trap, and exactly why multi-stage analysis is costing you so many marks.
Here is the absolute golden rule you need to remember. Cambridge physics isn't just about what you know, it is entirely about how you apply what you know. The syllabus uses highly specific assessment objectives. You have AO1, which represents your pure knowledge and understanding. That's your basic foundational definitions. But then you have AO2, which is application, and AO3, which is advanced analysis. The ultimate trap is that multi-stage questions strictly require you to seamlessly chain these different objectives together. When you are faced with a complex multi-stage analysis question, the examiner is actively trying to see if your internal logic breaks down under extreme pressure. Students bleed marks here because they aggressively try to jump straight to the final conclusion without ever showing the basic stepping stones of their underlying thought process. The crucial point to internalize here is that Cambridge examiners aren't just testing rote memory. They desperately want to see if you can successfully transfer your deep conceptual understanding to completely new, totally bizarre scenarios. They might give you a truly strange context, like evaluating the thermal properties of a deep space satellite in a total vacuum, or a specially designed experimental solar water heater in the desert. If you simply recite generic textbook facts without linking them, you spectacularly fail the context test. This is exactly where top students utilize the Peel framework. Point, evidence, explanation, link. Make your point about the core physics principle. Provide evidence extracted directly from the unfamiliar context they gave you in the question. Explain the actual scientific mechanism happening at the molecular level and link it firmly back to what the question actually asked. The poorly graded answer is always just a massive disorganized block of text. But before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, core radiation principles. We have to define the physics properly before we even attempt to solve the overarching problem.
This right here is the absolute bedrock of your entire exam strategy. If you don't get this fundamental concept correct, your beautifully structured Peel paragraphs will completely fall apart anyway. You absolutely have to clearly define the physics before you even attempt to solve the contextual problem they've thrown at you. So, before your pen writes a single analytical sentence in an extended response, you must quickly establish these foundational facts about thermal radiation. Listen very closely to this exact definition. Thermal radiation is infrared radiation emitted by all objects, which requires absolutely no medium whatsoever to travel. Let's break that down into its core components. First, it's infrared radiation, meaning it is a specific part of the electromagnetic spectrum. It travels at the actual speed of light. Second, it is emitted by literally all objects. Even a freezing cold block of solid ice sitting on a table is emitting thermal radiation. It's just emitting less radiation than it's simultaneously absorbing from the warmer room around it. And third, the absolute most critical part that catches everyone out, it requires absolutely no medium. This is the single characteristic that completely separates it from conduction and convection, which strictly need physical particles to transfer their energy. Thermal radiation can travel through the total empty vacuum of deep space. That is literally how the sun's life-giving energy reaches the Earth across millions of miles of nothingness. So, rule of thumb, if an exam question ever mentions a vacuum, your brain needs to instantly flash neon lights that say thermal radiation.
This perfectly illustrates the exact spot where thousands of candidates get completely confused every single year. You have to clearly, distinctly distinguish how a surface's color and texture independently impact three different things: emission, absorption, and reflection. Let's do a quick mental exercise together. Imagine the classic Leslie cube experiment from your school lab. You have a hollow, metal cube completely filled with boiling hot water. One side of this cube is painted a dull, matte black, and another side is polished to a shiny silver. A dull, matte black surface is the ultimate double threat in physics. It is the absolute best possible absorber of infrared radiation, and concurrently, it is also the absolute best emitter of infrared radiation. On the flip side of that coin, a shiny, white, or silver surface is a genuinely terrible absorber and a terrible emitter, but it is an incredibly outstanding reflector of infrared radiation. When our friend Sam aggressively rushed through his exam paper, he hurriedly scribbled down "matte black reflects heat." That one profoundly incorrect word cost him the entire question and dropped him a whole grade boundary. You have to lock these specific comparisons in your mind perfectly.
If you want to achieve those significantly higher marks, your written answers must confidently hit these three core theoretical pillars, especially when it comes to integrating cross-topic connections. First, precise definitions will consistently get you the initial, easy marks. Second, establishing clear causal relationships, for instance, explicitly stating that because a given surface is dull and black, it therefore emits infrared radiation at a significantly higher rate, gets you those tricky intermediate marks. But the third pillar, integration with completely different syllabus areas, is what guarantees you the A star. When you can seamlessly connect the concept of thermal radiation back to the kinetic particle model, or tie it into specific heat capacity calculations, or relate it to the broader properties of the electromagnetic spectrum, you are brightly signaling to the examiner that you don't just memorize isolated flashcards. You are proving that you actually understand how the physical universe fundamentally works.
Let's dive into Section 3, the technical methodology. This is all about the legendary method mark strategy.
All right, we've talked extensively about the theory. Now, let's talk about the exact, step-by-step physical execution you need to perform on the actual exam paper. This 5-step procedural framework is your ultimate cheat code for seamlessly processing complex data tables and multi-stage physics questions exactly how the Cambridge examiner wants to see them. Let's imagine Sam rewriting his disastrous answer using this exact framework. Step 1. Deconstruct the command word. Is the prompt asking you to state, describe, or explain? If it says explain, that strictly means you need to provide the why, not just the what. Step 2. Extract relevant data. If they give you a starting temperature of 60 degrees and a final temperature of 20 degrees, do not just leave those numbers sitting in the paragraph. Extract them and write them down immediately in your workspace. Step 3. Select your analytical framework. In this specific case, we are deploying the Peel method. Step 4. Execute with crystal clear notation. Don't just scribble a mess of numbers in the margin. Make your logical mathematical steps highly visible and sequential. Step 5. Present with correct terminology. Brutally swap out vague everyday words like heat or cold for highly precise scientific terms like infrared radiation or thermal energy transfer. By simply forcing yourself to slow down and applying this rigorous 5-step technical methodology, a messy, rushed, and panicked paragraph miraculously turns into a structured, highly scoreable response. Your mark potential literally shoots from 20% all the way up to 100%.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams.
@acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into the interactive workshop. Combining your robust data interpretation skills with strict formatting conventions is precisely what transforms a merely good answer into a genuinely perfect one. I am putting exactly 60 seconds on the clock in our minds right now. Imagine I flash a complex, highly detailed data table on the screen, showing the specific cooling curves of 4 dramatically different colored beakers over a 20-minute period. Challenge 1 is the data scan. Your job here isn't to meticulously read every single number in every single column. Your job is to rapidly extract the core overarching trend. You scan the initial temperatures. Okay, they are all exactly the same at 90 degrees. You scan the final temperatures at the 20-minute mark. Boom, the matte black beaker has the significantly lowest final temperature. What is the immediate, undeniable conclusion? The matte black beaker cooled the absolute fastest. Scientifically proving it is by far the best emitter of thermal radiation. If you can accurately extract that core relationship in under 60 seconds during an exam, your data interpretation skills are exactly where they need to be to crush this paper.
Now for Section 4, Critical Examiner Warnings. We are going to strictly focus on avoiding the top 3 principal examiner pitfalls.
We are going to look directly at the principal examiner reports to see exactly where thousands of students are needlessly bleeding marks every single testing series. Let me be clear. These aren't just my personal opinions. These are the officially documented, hair-pulling frustrations of the exact people who will actually grade your papers. Make sure you literally memorize this list because these are the top 3 devastating mistakes that will instantly sabotage your thermal radiation answers. Let's jump straight into Challenge 2 of our interactive workshop, Find the Flaw. I want us to mentally read a highly flawed sample physics paragraph together. Ready? The shiny blanket keeps the marathon runner warm because it reflects the cold away from their body. It is a bad absorber. Okay, your timer starts now. Spot the critical flaws. First off, saying it reflects the cold away is fundamentally, astronomically awful physics. Cold is not a physical entity or a wave. It is simply a comparative absence of heat energy. You cannot reflect an absence of energy. Second, it's totally nonspecific to the actual context provided. A shiny foil blanket keeps a recovering marathon runner warm by actively reflecting the runner's own emitted infrared radiation directly back toward their body. It significantly reduces their total heat loss by thermal radiation. By completely failing to use specific terminology and lazily using the wrong physical approach, that hypothetical student scores an absolute 0. Do not be that student. You must always forcefully tailor your precise physics knowledge directly to the highly specific, unique scenario they placed in front of you.
The official examiner reports explicitly demand this, so you should never, ever assume the examiner knows what you mean. You must spell it out clearly first. Let's tackle Challenge 3 of our workshop, Speed Writing. You have exactly 30 seconds to mentally draft a flawlessly executed Peel paragraph explaining exactly why the water pipes inside solar heating panels are always painted matte black. Go. Point. Matte black surfaces are the absolute best physical absorbers of infrared radiation. Evidence? The context provided is a solar panel actively absorbing electromagnetic energy directly from the sun. Explanation. Because a matte black surface absorbs a significantly wider range of the infrared spectrum much more efficiently than lighter colors or shiny surfaces, the water flowing inside the internal panel pipes gains thermal energy at a dramatically faster rate. Link. Therefore, purposefully painting the panels black directly maximizes the overall thermal efficiency of the solar water heater system. Boom. Stop the clock. You perfectly defined the concept, you flawlessly applied the specific context, you explained the underlying mechanism, and you just confidently walked away with full marks.
We have arrived at our final section, Section 5, the Exam Success Blueprint. Deconstruct, solve, evaluate.
We have comprehensively covered the hidden traps, the deep theory, the technical methods, and the harsh examiner warnings. Now I want to hand you the complete comprehensive system that top-tier candidates employ to consistently hit those A and A-star grades across the entire Cambridge physics syllabus. This is the ultimate deconstruct, solve, evaluate framework. It actively forces you to slow down your racing brain, check your underlying assumptions, and build an airtight, evidence-based conclusion. Let's look at the 3 unbreakable rules that essentially guarantee top marks. Rule 1. Command word decoding. If you don't actually know what the specific command prompt is asking you to do, you literally cannot give the right answer, no matter how much physics you know. Rule 2.
Strict Peel framework application. We've drilled this relentlessly today. In physics, your structural presentation is just as important as your factual knowledge. Rule 3 is the time management matrix. When you're sitting in that exam, you must immediately look at the number of marks available in the brackets. If a complex thermal radiation question is worth exactly 4 marks, you inherently need to provide at least 4 distinct, highly valid physical points or logical steps. Do not waste precious time writing a massive, sweeping paragraph for a tiny 1-mark question, and conversely, absolutely do not write a single brief sentence for a massive 4-mark question. When you systemize your entire approach, methodically identifying the given info, solving it systematically step by step, and brutally checking if your final mathematical answer actually makes logical sense in the real world, you completely take the dangerous guesswork out of physics.
Top-scoring candidates always take it one massive step further by consistently demonstrating this high level of critical, evaluative thinking, especially when looking at tricky surface effects and potentially flawed infrared data. If you are given a detailed description of a thermal radiation experiment, you must actively ask yourself, what are the hidden limitations here? Was there an undocumented draft in the laboratory causing rapid convective heat loss at the exact same time? Are we blindly assuming the initial starting temperatures of the beakers were perfectly identical down to the decimal point? By proactively acknowledging these potential alternative interpretations and solidly justifying your final analytical decisions with cold, hard evidence extracted straight from the provided data, you instantly elevate your written answer from standard average work to truly exceptional top percentile work. You explicitly show the examiner that you are critically thinking like a true, rigorous scientist and not just acting like a stressed student blindly repeating a textbook.
So I want you to really think about how you are going to approach your very next past paper. Will you blindly fall for the exact same thermal radiation trap that catches thousands of students, or will you purposefully use this rigorous methodology to guarantee your success? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.